Hello everybody, welcome to video number 2 regarding graphing parabolas. Video number 1, if you remember, we talked about conic sections in general, and then we started focusing on the parabola. And what we did was we explored the parabola with vertex at the origin. And we saw the creation of the parabola algebraically, and then we graphed some various examples, along with doing some solving of applied problems. Now, what we're going to do is we're going to analyze parabolas with our vertex somewhere else other than the origin. So, without further ado, this table that we have at the top of the page represents like what happens algebraically. And if you remember what I did with the other ones, I actually don't really look so much at what's going on the left, because I look at I kind of make a general sketch, and from my general sketch, I use the information or use the anatomy of the parabola to come up with that. So what I do focus on is the orientation of that equation. If it's y squared, I know that it opens left or right. If y squared's positive, it's right. If y squared's negative, it's left. If it's x squared positive, it opens up. X squared negative, it opens down. So I'm going to continue to look at that. But more specifically, if you notice, all of these are in the form of x minus h and y minus k. What that causes us to look at is that the vertex is at the coordinate h comma k. So when it comes to parabolas, you guys are used to seeing parabolas in that h comma k format, so we're going to continue that, but we're going to explore this still in more of its conic section form, but using h comma k as our vertex. So without further ado, I'm going to begin by looking at this problem, and the fact that this is y squared tells me it's going to open either left or right. But if you notice, this is not in our y squared equals 4ah form. So we need to factor out the -8. And by factoring out the -8, that becomes x minus 3. So we have y plus 2 squared equals -8 times x minus 3. And so the fact that it's y squared equals a negative means that it's going to be opening to the left. What I would like to do right now, and I really should have vertex listed here. Our vertex is h comma k. So our vertex is h comma k. Vertex h comma k. The h, remember, goes with the x. So the h is going to be 3. And the k, because that's a plus 2, is a -2. So our vertex should be at 3, -2. Let me go ahead and plot that. Screen's freezing, so let's unfreeze it. So the vertex is at 3, -2. If that vertex is 3, -2, that would be this coordinate right here. And I would like to label this with a V. I know that this opens up to the left, which means that I should put the V on this side. Okay. From there, what's our A value? Going back to what we did before, we know that 4A has to equal -8. So A should equal -2. In the last video, I factored out the -4 and then the A. So really our A is 2. I typically don't ask for whether A is positive or negative. According to what's at the table above, A should be a positive value. So I know this is going to open to the left, and my A value is 2. So if I go 2 to the left, there's my focus. If I go 2 to the right, there's my directrix. So the focus, the point of the focus is going to be 1, -2, and the directrix is the line x equals 5. Now, again, it froze up. So if you look at the top and you see h plus a, h minus a, all of that, yes, you can look at that and you can use that algebraically. I tend to do more of a geometric because it's a lot more efficient. The axis of symmetry is no longer going to be the x or the y axis. So if we draw that line through the focus and the vertex, that is going to be our axis of symmetry, which would be the equation y equals -2. The length of the last rectum is still going to be the same. That length is going to be 8. So if we go half of that, which is 4 above the focus and 4 below the focus, then we are going to get the other 2 points. So we need to create our parabola. All right, on to problem number 10. First things first, we do need to get the square by itself. So I have x plus 1 squared equals -12y. So negative 12y minus 36. And like before, we need to factor out that coefficient in front of the y. So that becomes y plus 3. Now, this tells me two things. Number one, the fact that it's x squared equals a negative, tells me it's going to open down. And that negative 12, if we break it up into negative 4 times 3, that tells me my a is 3. And so let me go ahead and throw vertex on here as well. Let's begin by plotting the vertex. The vertex is h comma k. So remember the h goes with the x. Let me highlight that. So the h goes with the x. So the h is negative 1. And then the k goes with the y. So that would be negative 3. So our vertex is negative 1, negative 3, which is this coordinate right here. And it opens down, so let's put the v right here. I know my a value is 3, so the fact that it opens down with the a value of 3 means my focus is here. And then let's go up 3 and create my directrix. So the coordinate of my focus is negative 1, negative 6. My directrix is just the x-axis, but let's go ahead and call that y equals 0. The axis of symmetry is right here through the focus and the vertex. That would be the line x equals negative 1. And then the length of the last rectum, once again, going back to not that, but that negative 12 value. The reason why that number is so important is because that gives us the length of the last rectum. So if I go half of that out, which would be 6 units, 1, 2, 3, 4, 5, 6. 6 this way and 6 this way, we will create our parabola. Now, like all things with the equations, any point along this parabola should be true. I know I haven't done this for many of the problems. Let's do this right now. This is a good way for us to check to see if our parabola is actually accurate. So this coordinate is 6, negative 6. So if I plug that back into the original equation, if I take 6 plus 1 squared plus 36, does that equal negative 12 times 6? So 7 squared is 49. That should be at negative 6, by the way. 49 plus 36 is, and my pause was, oh, wait a second, something's wrong. That's not 6, negative 6. That is 5, negative 6. That makes a huge difference. This is why we check ourselves. So 5 plus 1 squared plus 36, that's now 36 plus 36. That should equal 12 times 6, which is 72. So 72 equals 72. So the whole point of that was checking to make sure that we're okay, or that we're correct. And it helps when you have the right coordinate. Last but not least, we're going to be faced with problems that look like this. This is a little bit more of what we call the standard form, and we'll see this as we explore the rest of chapter 10. The fact that this is y squared means I am going to have to get the y's by themselves. So there's going to be some completing the square that we are going to be doing some work with. Let's bring all the other non-y's to the other side. To complete the square, if you remember, we will take half of this b term, so negative 4 divided by 2, and square it. So 2 squared, negative 2 squared is 4, so y squared minus 4y plus 4 will equal 16x plus 64 plus 60 plus 4, which is 64. So our equation will be y minus 2 squared equals 16. Let me simplify that up here. If we factor out the 16, we will get x plus 4. So that tells me my vertex. My vertex should be at the coordinate negative 4, comma 2. Let's go ahead and plot that. Negative 4, comma 2. And does this open up, down, left, or right? Because it's y squared. The fact that it's y squared means it's going to open left or right. Because this is a positive value, it's going to open to the right. So let me put the v right here. So our vertex is there. What is our a value? Our a value, if we know 4a is 16, that means that a will have to be 4. So if I go 4 to the right, That's where I get my focus. And again, I'm going to the right because of the orientation. If I go 4 to the left, I will get my directrix. Let's go ahead and fill in that information. Our focus is at 0, 2, and our directrix is the line x equals -8. Now our axis of symmetry does go through the vertex and the focus. That would be the line y equals 2. And the length of the last rectum, once again, we will get from that number, so that length is 16. So if I go half of that up, I will get one part of the, or I will get one endpoint of the last rectum. And if I go half of that down, I get the other point. And I just saw that I didn't have that there. And let me try to draw that a little bit more accurately as well. So there's our parabola. So the graphing is very, very similar to how we graphed before. This is just going to be different in terms of, hey, we have to find our vertex first. Now, hopefully I didn't make that look too easy for you, because if we start off with all that information directly given to us, it makes life a little bit easier. If we don't have it given to us immediately, then we are going to have to do some mathematics to get to that point. And it's very easy to make mistakes somewhere and not catch yourself, which is one of the reasons why I checked. And I'm glad I checked, because I caught a small mistake that I had. So. And then we're going to get problems where you're going to have to find the equation based off information. We did this before. We did this with the vertex at the origin. So it's kind of like those problems right there. This time, vertex doesn't necessarily have to be at the origin, as evidenced by here. So if you remember, what I did before was I kind of made a quick sketch. And if my vertex is at -3, 2, that's about right here. So there's my vertex. And then if my directrix is x equals 3, let's draw an x equals 3. How am I supposed to figure out what this looks like based off of this information? Well, if I know that my vertex is to the left of my directrix, I know that the parabola goes away from the directrix and the focus should be somewhere over here. So with that said, I know that this is a parabola opening to the left, and a parabola opening to the left would be y squared. I'm going to write it this way because we do have the vertex somewhere else. Y squared equals -4ax. So the fact that my vertex is to the left of my directrix, I can immediately go to that information, but it's a lot easier to actually just see the graph and go with that. This is where I'm going to plug in my vertex. Remember, the k goes with the y, so y minus 2 squared equals -4a times x minus -3. Let's just go ahead and put that as x plus 3. And so now I'm very, very close to having the equation. All that's left is to figure out what my a value is. And so my a value is going to be that distance from the vertex to the directrix. If I know that this is x equals 3 and this is -3, -2, that means this total distance, probably should have chosen a different color on that one, that total distance is going to be 6. So I have y minus 2 squared equals -4 times 6 times x plus 3. So y minus 2 squared is -24, x plus 3. So as we go on to the next problem, it's like a problem 13. Like before, we are going to go ahead and sketch this out. So my focus is at 5, 11, so 5, 11 should be right about there. My vertex is at 2, 11, which should be right here. Now the fact that my vertex, or my focus, or the parabola wraps around the focus, that tells me this parabola is going to be opening to the right, and opening to the right would be y squared equals the 4ax. And I do know my vertex, so let's go ahead and generically write it out as y minus 11. Remember, that's my k value. Y minus 11 squared will equal 4a times x minus the k, which is 2. And our last bit is to figure out what is our a. And if you remember, our a is our distance from our vertex to our focus. There is our a. So what's the distance between 5 and 2? That would be 3. So y minus 11 squared will equal 4 times 3, which is 12, times x minus 2. Last but not least, we have one more problem. So let's make our axes. Our vertex is at 1, -1, so 1, -1 would be right there. Let's go ahead and label that a V. V. Our axis of symmetry is x equals 1. X equals 1 would look like that. So let me go ahead and write that as axis of symmetry. And then our parabola contains the point 0, -3. So 0, -3 would be right about here. So this is the point. This is not the focus, remember. This is just some kind of point. Now, we have a couple different options. So does our parabola open up like that? Does our parabola open up like this? Does our parabola, what are another option? Open up like so. It could open up in a variety of manners, except the fact that this is our axis symmetry, which means if we have a point there, we have to have a point here, which should tell us that our parabola opens down. So this should be of the form x squared equals -4ay. Let's go ahead and put that vertex point in, and that vertex point would say x -1 squared will equal -4a times y plus 1, and that plus 1 again comes from that -1. So this is our generic form that we're going to begin with. Now, I don't know where my focus is. My focus could be anywhere. So the fact that I don't have a focus means I have to figure out what is going to be my a value. To figure out the a value, that's where I'm going to use this point that the parabola contains to say my x value is 0 on that point. And again, we're using this 0, -1. That x value is 0 minus 1 squared will equal -4a times y. My y value is not just y, it's -3. So I will have 0 minus 1 squared, which is 1, equals -4a times -3 plus 2, -3 plus 1. I'm jumping ahead of myself, so that's -2. So 1 will equal 8a, so a is 1/8. And that is what I'm going to put in to my generic equation of x -1 squared equals -4a. So -4 times 1/8 times y plus 1. And -4 times 1/8 is -1/2. So I have x -1 squared is -1/2 times y plus 1. And there is my last equation. So hopefully you found this informative, and I'm looking forward to introducing the next section to you. The next section is going to be about ellipses. Have a great day, everybody.